Now I will talk about the definition of divides. Okay, so the first thing I should say about divides is that this only makes sense for integers. Positive or negative whole numbers. It only makes sense for whole numbers. Positive or negative or zero. All right. All right, so let's say, okay, let's do, I don't know, let's look at, say, 12. Now I'm going to motivate the definition of divides. Okay, so this is not the definition, but I'm going to motivate it. Let's look at 12 over 4. 12 goes into, or 4 goes into 12 evenly, right? It goes in 3 times. Right, so with the definition of divides, it just makes more sense to think of things abstractly, or to look at this more instead of looking at it like this, we look at it with like this. Okay, so we say that we say that 4 divides 12. 4 divides 12 because there is a number in this, or an integer, and it has to be an integer because there is an integer, in this case 3, such that 4 times 3 equals 12. Okay, so the way that we would write this, so let me write it like this. We'll write 4 times 3, this is a times here, 4 times 3 equals 12. Okay, so since this is an integer, since that's an integer, and it has to be an integer. Okay, since that's an integer, we say that 4 divides 12. So 4 divides 12. And so mathematicians are lazy. Mathematicians are lazy. They get tired of writing words out. So we always come up with symbols for things. So instead of saying 4, instead of writing 4 divides 12, what we would write instead is 4 divides 12. And it's just a new notation. So whenever you see something like this right here, what we're saying is there exists some integer such that 4 times that integer equals 12. In this case, in this example, it's 3. And you can see here that as well that 3 divides 12 as well, right? Because there's some integer, namely 4, such that 3 times 4 equals 12. All right, so I can't emphasize enough that the number that you multiply to get the number has to be an integer. All these numbers have to be integers. This definition doesn't work anywhere else except for with whole numbers. It'll work in the natural numbers. It'll work in the integers, but it will not work in the rational numbers. It doesn't work in the real numbers or the complex numbers. So this definition is only for integers. Let me emphasize that again. Only for integers. Dun dun dun, only for integers. Okay. All right. I think maybe I've emphasized that enough. Now next, let's see here. Let me show you why that we have to have integers to do this. Okay. Why this only makes sense for integers. Okay. Well, actually, before I show you that, let me just first write down the definition. Okay. So we say that an integer a divides b if there exists, and I'll use this symbol because I'm lazy, if there exists integer k such that a k equals b. And soon, once we get through, we'll get into section 3, we'll be able to abbreviate this as well. The integers are a set. Once we get into sets, then and we have symbols for sets, then I'll get even more lazy and I won't even write out the word integer. But for now, I have to. Man, my arm hurts. Okay. So why does this only work with integers? Let me show you. All right, so the reason why this only works with integers is because if we were to say, okay, let's extend this definition to rational numbers, these are fractions, right? Then anything can divide anything else. Let's see. Let's look at two numbers here. How about let's use 5 and 12. Okay, so it's commonly known that 12 is not evenly divisible by 5, right? But if we extend this definition of 5 times something equals something else, 5 times something equals something else, right, to mean that divides, well, then we can put anything we want here. So notice that if I'm allowed to use fractions, right, remember the real definition, this is only an int, right, has to be an int. But what I'm saying is if we allow this to be something that's not an int, right, that's not an integer, then we can make anything divide anything else just simply by going like this. Right? 5 times 12 over 5 is equal to 12. Right? So it doesn't make sense. The concept of divides simply doesn't make sense when this is not an integer. Okay, so divides only works for integers.